Okay, in this video, I'm going to go over dividing rational expressions. And there's a couple of variations that I want to go over because these can get a little complicated. I'm just going to go over two different variations for you, okay? So let's start with a real simple one. We'll call this example 1. So let's start with something like x squared plus 2x plus 1 divided by x plus 1. So when you're dividing two rational expressions, remember that the word rational expression just means a ratio of polynomials. So we have a ratio of polynomials here. What you need to do is to factor both the numerator and the denominator. So we'll factor this one up here, x plus 1, x plus 1. The denominator is already factored, so we'll just leave it as x plus 1. And then what you do is that you cross out or factor out any ones. So let's just say cross out any ones that result. Okay, for example, x plus 1 over x plus 1 is a 1, so it doesn't really need to be needed. You're left with x plus 1 as your final answer. Okay, so that's how a very simple example of dividing rational expressions. There's another video that I did where I just called it simplifying rational expressions. Okay, so you might find other videos listed under that particular title. Okay, now the more complex one that I want to do for you looks like this. So we'll call this one example 2. And let's do something where we have a rational expression fraction divided by another rational expression. Okay. Now, this is something that we call the stacked method. All right. Or at least I call it the stacked method. And what you have to do here is look at this with a different set of eyes, is what I call it. You're trying to identify what the simpler problem is within the larger problem. One of the things I love telling my students is that difficult problems are just a bunch of simple ones stacked together. And this is a perfect example of that. So look at that fraction as separate from that fraction. And this is like the big division sign, right? Now, how would you solve, or how would you start to simplify something that looks like that? Well, the clue is when you were actually dividing whole numbers. So let me just go off to the side here and give you an example of using just regular whole numbers. If I had something like 1/2 divided by 1/4, how would you solve that? Or how would you start to simplify that? Well, I think you remember back in earlier math classes, you just divide, or multiply rather, by the reciprocal. So you'd say 1/2 times 4/1. And then essentially what you do is you convert this into a multiplication problem, right? That turns out to be 1/2, and then you can just do 2 times 2/1, cross out the 1 there, and look what you got. You got 2/1, or just 2 simplified, right? You essentially do the same thing over here. So once you've identified the two different fractions, go ahead and multiply by the reciprocal. So x plus 1 times x squared plus 2x plus 1 over x squared minus 1. And then you do the exact same thing that you did with a multiplication problem. Factor every single one of these individual polynomials. That one's already factored. That one's already factored. This one could go to x plus 1 times x plus 1. This one's factored to x plus 1 times x minus 1. And now you start crossing out all the common factors that equal 1. So there's one there. There's one there, and your final answer is 1 divided by x minus 1. Okay? I hope that was helpful.